Let's start with what I consider to be the easiest of the transformations, which is k. So I want to look at y equals f of x, so basically my parent function plus k, and I think we're going to use the example of y equals x squared plus k. K is happening after my x variable has gone through the function of squared. So I have, here's my function machine. Let's come out here. Here we go. Here's f. Here's my x, goes in there. And then in this case, my f of x is equal to x squared. That's my parent function. So x kind of goes, let's make it. X goes in here, it gets all squared, and just before it pops out, or you might even say right at the end of the function machine, I add a k. Let's say that the actual function is f of x equals x squared plus 2. And so we drop variable 3, we drop x, 3 equals x equals 3 into this. So we have 3, that's what gets squared. So, and then we're going to add a 2 to the end of it. So that's going to give me 9. And then once my 9 pops out of the squaring function, I add 2. So I get 11. Let's take a look at an example. So I have my graph, my parent function, y equals x squared. And when I evaluate that at 3, here's 3, my answer is, my f of x is 9. So that's the answer right there. Now I'm doing, I add the k. This is y equals f of x plus k. I'm adding 2. Well, let's take a look at it here. Calculate it. Now evaluate it at 3. I've gone through the squaring process, and then I add 2. So now I have, the answer is 11. So I've raised, and that happens for every single point. If I'm evaluating f of x, my parent function is 0, and I go to my child function, x squared plus 2, I'm just adding 2 at the end of every single value. Here at 1, 1, it goes to 1, 3. Here at 2, 2, 2, 4, it goes to 4, it goes up to 6, 2, 6. At -3, it was 9, and now at -3, I added 2, and I go up to 11. So after my x goes through the squaring process, after my x goes through the function, I add my k, which is 2, and I just raise the graph vertically by those 2 points. Let's just look at the k for a different parent function, a parent function of x cubed. So now I'm going to look at what happens when I go add a k of 2. It jumps up 2 in every single spot. Looks a little bit different than it did, not quite as symmetric as the parabola for x squared. But at my parent function here, where x is equal to 0, my y was equal to 0, so I had that point 0, 0. After it goes through the function machine, it jumps up 2. At 1, it was 1, 1. After it goes through the function machine, I add the k, it jumps up to 1, 3. Well, you can't really quite see it at 2. At 2, it went up to, as you can, at 2, it goes to 8. That's in my parent function right there. And after it passes through the parent function, I add my k, which is 2. So on my other one right there, it's evaluated at 10. Similarly, if I go to negative 2 on the parent function. That would have brought me to negative 8 right there. But I'm adding 2 after it goes through the function machine there. So it's x cubed plus 2, so that it goes up to negative 6. So that's pretty much how the transformations work when we're dealing with the k.